Glad you guys could join us. All right, so first thing is understanding the steps, okay? So, and why we have to use complete the square. So last time, just to kind of recap, we were solving quadratics using square root, right? So we had this set of notes. And what was nice about it was that we already had the term or the expression inside parentheses with the power on the outside. So typically all we had to do was isolate that parentheses, then we could apply the square root and we could solve from there. But what happens, what happens if you don't have the quadratic inside of those parentheses, right? Like what would you do from there? And that's what kind of today is all about. So when you look at the quadratics that we're going to get, they're not going to be in vertex form, right? I kind of call it vertex form because you could have gotten the vertex from it, right? Your H and your K. But what happens if they're not in vertex form? What happens if, let's say, they're in standard form, okay? And what is standard form? So in box number 1, I'm going to go through what the steps are to complete the square on a quadratic so that then you can solve it. All right, so standard form quadratic, just to recap, takes the form of ax squared plus bx plus c equal to 0, okay? So the key feature here is that the quadratic is all on the left side, or, you know, all on one side together in descending order, right? The power of 2, then the power of 1, and then you have your constant. Okay, a, b, and c, those are all constants, okay? You can, or coefficients, a and b coefficients, and c is a constant. Okay, so the first thing, okay, so right now the steps aren't going to make too much sense because we're not really working through a problem. So let me just write out the steps for us, and then we can refer back to them every time as we're moving through the problems. All right, so for number 1, first step. Okay, the idea here is to first move c, which is your constant, okay, to the other side. Okay, that's typically kind of like counterintuitive. You're just like, why would I move it to the other side? Typically we've been told move everything to one side. Okay, so a lot of it is kind of like anti-conventional, okay, but just kind of follow with me here. All right, so we move the constant to the other side of the equation. Okay, that would be step 1. Step 2 would be to divide every term by a. Okay, and the reason why we want to do that is because we want the leading coefficient to be 1. Okay, leading coefficient needs to be 1. Okay, all right. Sometimes the leading coefficient will already be 1, so then sometimes we're just going to skip step 2. All right, so step 2 is there as like if needed, right? So if the leading coefficient is not 1, then we have to go through and divide everything by that number so that the leading coefficient will be 1. All right, but again, that's a step that sometimes we'll skip. It won't always be necessary. All right, okay, then we get to step 3. Step 3 calls us to divide b by 2, then square it. Okay, so basically step 3, you're going to do b over 2 squared. Okay. Number 4, step 4 is whatever you got from step 3, right? After you take b, you divide it by 2, you square it, whatever number you get, you're going to add that to both sides of the equation. Okay, so it's a balancing that you do in number 4. Okay, so what I'm going to say here is you're going to add result from step 3 to both sides. All right. Okay. And then once you've done that, the next step is going to be to factor. So you're going to do some factoring. And then the last step is to solve. Solve for x. Okay. So it seems like a lot, and sometimes it is, but actually it's a little bit simpler once you actually start doing the problems. All right. So the steps are there, but again, it's not. It does not as much as it seems. Okay. All right. So let's start with our first one, and you'll see how the steps kind of fall into place, and it makes a lot more sense. Okay. So if my first example here is I'm given x squared plus 6x plus 4 is equal to 0. What I want to do is notice how, first of all, this is in standard form, right? So it's not in vertex form. So that means that you can't just apply a square root because, first of all, the expression is not inside the parentheses. If you don't see an expression where the terms exist within the parentheses, you cannot use the square root method, right? The square root method is a very special type, and it only works in certain scenarios, right? Notice how all of these types of problems, you had an expression inside the parentheses with a square on the outside. And that's when you were allowed to use it. But in this case, we don't have that scenario, right? Everything is kind of separated, it's extended, it's in standard form. All right, so now let's kind of move through the process, all right? Let's kind of see what we're gonna do here. Right now, the whole point of completing the square is to be able to create a trinomial that can be factored, right? Right now, it's not. If you take a look and you try to factor this trinomial, it wouldn't be possible because the factors of 4 are either 2 times 2 or 4 times 1, but they don't add up to be 6, right? 4 times 1 is 5, and 2 times 2, you add that up, that gives you 4, right? It doesn't add up to be 6. So this is not factorable. So the whole point of completing the square is to transform the current quadratic into something that is factorable, okay? That's why factor the trinomial is step number 5, because eventually when we get down there, you're gonna be able to factor something, and when you factor something, then you're gonna see why then you can use the square root after, okay? All right, so let's just go through the steps. Let's see what we get. So the first thing is first you move c to the other side. The c is the constant. So you're going to move the term that doesn't have a variable. So first you want to subtract 4. All right. When you subtract 4, that's gone. Now you're left with x squared plus 6x. I'm going to leave a space right here. Okay, I'm going to leave a space for a reason. I'm going to leave a little space here. And then I'm going to leave this as -4. Okay. All right. Now, I know that eventually I'm going to need to add something to both sides, so then I'm also going to put another little space right here, okay? You'll see why I'm doing that in a bit. Okay, so first we move the constant. The next thing then is to divide every term by a. Well, in this case, what's my a? Well, since there's no number in front of x squared, it's a 1, right? So because it's already a leading coefficient of 1, this is when we get to skip, right? We don't have to divide everything by 1 because if we did, we still get the same thing, okay? So in this is the scenario where I don't need to do step 2, okay? Because it's already taken care of for me. The leading coefficient is already 1, right? So then we get to skip to step 3. Here's what you do in step 3. You're gonna take your b value. In this case, your b value is 6. You're gonna take 6, you're gonna divide this term by 2, and then you're gonna square it, okay? So when you go ahead and do that, notice 6 divided by 2, well, that's going to be 3. And now it's just 3 squared. 3 squared, that's going to give you 9. Okay? So what are you going to do with that 9? Okay? Well, now that you've divided b and you've squared it and you get 9, step 4 says to add that result to both sides. So that's why I left a little space there on both sides of the equation, because then I knew I was going to go ahead and add both sides by a 9. Okay, where does the 9 come from? The 9 comes from what we got from b over 2 squared. Okay, so why is that value of 9 so important? Well, now I want you to look, first of all, Take a look at the left side of the equation. You have x squared plus 6x plus 9. Can you factor that? And if you can factor it, what would it be? Okay, so regardless of how you do your factoring, what I want you to notice here is, oh, we got a chat. We got something in the chat. Where is my chat? It's like hiding somewhere. Oh, here it is. Yeah. Good. It would be 3x plus 3 times x plus 3. Good. Okay, so this factors into x plus 3 times x plus 3. Okay, and at the same time, let's go ahead and clean up the other side of the equal sign. Negative 4 plus 5, I'm sorry, negative 4 plus 9 is equal to 5. Okay, now, this is the part then where, do you notice that x plus 3 times x plus 3 is the same factor written out twice? So would you agree with me that you can also write it as x plus 3 to the power of 2 is equal to 5? Would you guys agree that that's the same thing? Right? Yeah, we're getting some yeses. Okay, so why is that the ultimate goal, to get the equation back into that point? Because now we can then go back and solve by using the square root method. Okay, because I have a parenthesis with the power of 2 on the outside, now I can then apply square root to both sides. Okay, do you see what we did? We took a quadratic that was not even factorable. We were able to add something to both sides, right? That particular number that we were able to add to it allowed it to then become factorable, right? Now, it seems like, well, we randomly added 9. Well, randomly, not really, because it came from B, right? The fact that we took from B divided by 2 and squared it told us that 9 is the specific number we need to be able to factor it, and it then becomes factorable where it's the same term times the same term. This right here that we had created right here is called a perfect square trinomial. Okay, this right here, perfect square trinomial. Right, so they're rare. Okay, they are trinomials that again allow you to have the same factor times itself. Okay, so by doing so, we can then solve this for x. Okay, whereas before we didn't have that option. All right, so now we can go ahead and apply the square root from both sides, and then we get to use what we learned last time. Okay, so if I apply the square root, let me zoom in here. This is the solving process, right? So this is step 6. Now we can go ahead and cancel these out. We have x plus 3. This is going to equal the square root of 5. Remember that you are always solving a quadratic to begin with. So please do not forget that you have a plus and a minus there, okay? So now, in order to solve your solutions, to get your two solutions, remember that you're just gonna move the 3. You're gonna subtract 3 to both sides, okay? So now this cancels and you're left with x is equal to, and remember that the negative 3, this is a full value. This is a whole number that does not mix with the square root of 5. So they're going to stay separate, all right? So you're going to have negative 3 plus or minus root 5, okay? And then that's my solution right there. Okay, so any questions so far about what we've done? Hold on. I know most of you guys are like talking through the chat. I don't know why it keeps hiding on. Hold on. Okay, here it is. How do I feel like one of those teachers that like doesn't know what's going on right now, because I want the chat to show. All right, whatever. Okay. All right, we're okay so far. And please, if at any point, just please feel free to just unmute yourself and ask a question. No one's gonna make fun of you, I promise. Okay. All right. Okay, let's move on to another example. Okay, let's just get in the habit of All right, we gotta. I was gonna make fun of me, but myself. Okay. All right. If you want to. Okay. All right. Example 2. Let's take a look here. All right. So we have x squared minus 4x plus 1, and that's equal to 0. Okay. All right. So again, I have a quadratic, but it's in standard form. I cannot at this moment apply square root. Okay. So I need to go ahead and go through the complete the square process. Complete the square process tells us to first move the c value, which is our constant, move it to the other side. So in this case, we're going to subtract 1. That one cancels. So we have x squared minus 4x. I'm going to put plus, and I'm going to leave a space here. And then that's equal to -1. And then I'm going to put a plus and a space here. Okay. And I'm leaving those spaces open because that's kind of my reminder that I eventually have to add something back to both sides. Sometimes the mistake happens is like you always add it to the left side, but you forget to add it to the right side. If you add something to the left side, but not the right side, you didn't balance the equation. So what you did was like an illegal move. All right. So that's why I like putting the little underline on both sides of the equation. Is a mental reminder that then I have to go back and add to both sides. All right. Okay. So then from there, what we want to do now is, right, number 2 is to divide each term by a because we want the leading coefficient to be 1. Well, in this case, our leading coefficient is already 1. Right? There's an invisible 1 there. So there's no need to divide everything by that value. We're not there yet. We will get to those types of problems. But for now, we get to skip. Okay, so for that, then that takes us to step 3. Step 3 is take b over 2 and square it, right? So then in this case, what's our b value? Our b value is -4, okay? It's -4. So then you take -4, you divide that by 2, and then you're gonna square, okay? So then from here, that gets us -2, and we square that. So then that's just a 4, right? +4. Regardless, even if you end up making a mistake there with that negative, when you square something, if it's negative and you square it, it's going to become positive. If you take a positive and you square it, it becomes positive, okay? So the key thing is that keep that negative inside the parentheses, because if you at some point make a mistake, you don't put those parentheses, and then you take -2 squared and you type that into a calculator is going to tell you -4. You're never going to subtract something from both sides of the equation. You're going to add something to both sides of the equation, okay? So you're going to add the 4 to both sides in this case, all right? Okay, so now the left side, right, where are we? You added the results to both sides, right? That's the adding 4. Now we factor the trinomial. The trinomial should be a perfect square trinomial, which means that the factor should always be the same thing times the same thing. Just like before, we got x plus 3 times x plus 3. It should always be the case in every problem where your factors are the same, okay? So in this case, what do you think the factors should be, okay, on the left side? What is it going to factor into? You want factors that will multiply to be 4, but add up to be -4. So what do you think? Yeah, so remember, it has to be both. Yeah, both of them have to be the same number. So we want x minus 2 times x minus 2. Okay, if you did x minus 2 and then x plus 2, then you wouldn't be able to write it as the same term squared. Okay, so then what you want to make sure here is go ahead, add the right side. That's going to give us 3. Here, you want to make sure they are the same. Okay, they have to be. Otherwise, the next step doesn't quite make sense, right? Like if you had x minus 2 and x plus 2, then you're not allowed to write it as like x minus 2 squared because it's not the same, right? So always make sure that what you have is the same factor twice, okay? The product of the same factor twice. So now we can then rewrite this as x minus 2 squared, and then that's equal to 3, okay? And that's your goal, right? You always want to reach that point where you can write the same term squared, because then from there, that allows you to use the square root method. And then the square root method is going to get you to your solution. All right. So let's go ahead, square root both sides. Square root, you're going to get x minus 2. Okay. On the right side, remember that square root of 3 does not simplify. Do not change it to a decimal. Leave it as the square root. But because you were solving a quadratic, that means you need 2 solutions. Don't forget to bring down the plus or minus. Okay? Okay. So now, x minus 2, get x by itself. Go ahead and add 2 to both sides. Okay? 2 is going to cancel. And here you're going to be left with x is equal to, well, the 2 is a constant, right? It does not mix with the square root of 3. You want to then write this as 2 plus or minus root 3. Okay, keep the 2 separate from the square root 3 with the plus or minus in between. Okay. And then those are your 2 solutions right there. Okay. How do we feel so far? Are we doing okay? Doing good, doing good. Okay. All right. Okay, so then that's kind of the basics, right? So the steps really aren't as bad as they seem, right? It's a lot. It seems like a lot, but it's not that much. So let's try a couple more. And let me grab those. I have them here. Okay, so I think we haven't done that one yet. Okay, so x squared minus 6x minus. All right, example 3. All right. Okay, so here, first step, right? Add the 3. It's going to cancel here, and we get x squared minus 6x is equal to 3. Okay, remember you're going to add plus with a space here, and then plus with a space here. Okay, serve as a reminder. Okay, so now we take b over 2 squared. The b value is -6. You're going to half it. You're going to divide it by 2 and then square it. So you get -3. And when you square that, you're going to get 9. Okay, so now we go ahead and add 9 to both sides. All right, this is it's a little different, slightly different from what we got the first time around, because now it's x squared minus 6 versus before it was x squared plus 6. Okay, so here the 2 factors, what are they going to have to be for us to be able to factor that as the same term times the same term? Yeah, so we get x minus 3 this time. Okay. Whoops. And then that's going to equal to 12. All right, so we can then say x minus 3 squared is equal to 12. And now we're in a position where we can apply the square root, okay? So let's go ahead and do that. Square root both sides. Square with square root will cancel, and you can bring down the x minus 3. Square root of 12, that's a number that you can break down using a factor tree, okay? So we have 12, that becomes 4 times 3. And then 4 becomes 2 times 2, okay? So 2 times 2, that's going to then allow us to move the 2 to the outside. The 3 is the loner here, so that becomes 2 square root of 3, okay? So now we have x minus 3 is equal to 2 root 3. But because we were solving, we're looking for 2 solutions. Don't forget the plus or minus here, okay? So we're almost done. We just need to move the -3. Want to add 3 to both sides. okay? So remember, right, when you're adding 3 to both sides, since the 3 that I put in red, right, that we're adding to the other side, since that 3 does not have a square root of 3 behind it, that means that these are not like terms, okay? So 2 root 3 cannot be combined with this 3, okay? Because this 3 in blue does not have root 3. So it's not a like term, so those have to stay separate. Okay, so your solution will need to say 3 separated from the 2 root 3. So you put 2 plus or minus 2 root 3. Okay, that's going to be your solution to this quadratic. Okay. Are there any questions there? We're good. Okay. All right. Okay, so now let's try a couple more. Let me go ahead and adjust this real quick. Okay, so now let's see what happens in the event that we do have a constant that is not one. Right? Let's say we have a quadratic that does not have a leading coefficient of 1. So for example 4 here, let's say you're given now 2x squared minus 12x plus 14, and that's equal to 0. Okay, so far everything we've looked at, the leading coefficient was 1. Now what happens if the leading coefficient is not 1? Well, remember there's an additional step there that takes care of this for us, right? So step 1 is still that you move c to the other side, but then when you get to step 2, you're going to divide every term by a, right? So if a happens to be, let's say 4, then you would divide everything by a 4. In this case, the leading coefficient for us is a 2, so you divide everything by a 2, okay? Eventually what you want is that you want the leading coefficient to be 1, right? Because then that helps you factor, right? It helps you factor in a much easier way, okay? Okay, so let's start here. 14, gotta go. First, subtract 14 from both sides. So you're looking at, oh, okay, let someone in. All right, so you're looking at 2x squared minus 12x. This is gone. I'm gonna leave a space. Actually, for now, yeah. Okay, so this is what we have so far, right? I've kind of left some spaces there, right? We'll fill them in eventually, okay? But for now, the priority is first divide every term by the leading coefficient. The leading coefficient in this moment is 2, so you divide everything by a 2. Okay, so divide here by 2, divide this term by 2. There's nothing here yet, so you're not going to divide anything by 2. And then you divide the negative 14 by 2. Okay? All right, so then here, obviously, the 2's divide out. You're just going to get x squared. Negative 12x divided by 2 will give you a negative 6x, right? Still leave your space holder here. Okay, we're going to fill this in. Negative 14 divided by 2 will be a negative 7, and then you still have your space holder. Okay, so now you're in a position where that leading coefficient is 1. Now we can move on to step 3. This is where we can then take b over 2, we can square it, and then we can move on. Okay, so that's the only additional step that you need when this leading coefficient is not 1. All right, pretty simple. Just divide everything through by that number. Okay. All right, so now from here, I got negative 6. I'm going to take negative 6 divided by 2, and then I'm going to square it. You can see that negative 6 divided by 2 is negative 3. And negative 3 squared is equal to 9. Okay, so then we're going to go ahead and add 9 to both sides. All right. So from here, go ahead and factor, right? We've seen this before. Like I said, the perfect square trinomials, there's only so many of them, all right? So you're going to end up getting like the same expressions like over and over because there's only so many, all right? So then in this particular case, what we get now is going to be x minus 3, right? Because negative 3 times negative 3 will give us positive 9, but it adds up to be negative 6. So you get x minus 3 times x minus 3 is equal to negative 7 plus 9 is just 2. Okay, so now we get x minus 3. We can rewrite this as x minus 3 to the power of 2, and then that equals 2. So now we're in a position that since we have the term inside the parentheses with the power of 2 on the outside, we can then go ahead and square root it. Square with square root will cancel, and we're left with x minus 3. On the right side, that's a square root of 2 that cannot be reduced, but because you're solving a quadratic, you need a plus or minus. Okay, so we're almost done. From here, add 3, add 3. Okay, x will equal, the 3 does not combine with the square root of 2. They have to stay separate. Okay, so you have 3 plus or minus root 2. And there's your solution there. Okay, so not a big deal if the leading coefficient is not 1. It's just one additional step to just divide everything by a 2. All right, after that, no big deal. You keep going, business as usual. All right, how we doing? Any questions so far? Check the chat here. You have a question? Yeah, tell me. But not on math. All right, tell me anyway. What's going on? Unless you want to send it to me privately. You don't have to tell everybody. You can change here your option. Is it? Yeah, I'm gonna put the recording on Schoology. Yes. Okay. Yeah, I'm recording it live now, and then I upload it after. It just takes a couple hours because it's a long video, and just it doesn't do it as fast as I would like it to. Okay. But otherwise, everybody else, how are we doing? Okay. Any questions? Anything that's not making sense? Do we feel comfortable yet? You can always give me a reaction too. You can send like a thumbs up or something. All right, thumbs up. Cool, cool, cool. Okay. All right, let's try one more, and then I think we'll be okay. All right, so example number 5. Let me pull up the problem that I want to get. Yeah, let's try something ugly like this last one here. Okay, so 3y squared plus 5y plus 9. Okay, so we got 3y squared plus 5y plus 9 equals 0. Okay. All right, so first thing here, stick with the steps. You want to go ahead and move the c. So subtract 9 from both sides. Cancels out for you. So you're left with 3y squared plus 5y plus a space, okay, because we're going to add something there eventually, is equal to negative 9 plus a space. Okay, so we'll get there. What comes next? Okay, you need to go ahead and divide everything through by the leading value. In this case, the leading value is 3. So you have to divide everything by 3. Okay, now when that happens, sometimes you're going to get something kind of ugly, all right? Happens, all right? It happens sometimes. The 3's cancel, that's nice. You get y squared. However, 5 divided by 3 does not cancel, all right? So you're going to have to write that as 5 over 3y. Okay, here nothing got divided because we didn't have a number there. That was just the empty space holder so that we can bring things down. Okay, negative 9 divided by 3, that's a negative 3. And then nothing got divided out here. Okay, so this is where the most challenging part of completing the square comes from. And this is where sometimes the benefit of a quadratic formula overrides what the complete the square can do. Okay, in problems like this, because look at what we have to do now. You have 5 divided by 3. Remember that now you have to take b divided by 2 and then square it. So what, like, how is that, you know, you're gonna have to take a fraction divided by 2 and then square it. It becomes a little bit more challenging. So remember, b over 2 squared. Okay, so I'm gonna try to take this slow. B is the whole thing, right? 5 over 3. So you take 5 over 3 and you're dividing this by 2. Then the idea is to square this. Okay, but it's like, what exactly am I looking at? Okay, well, let's just kind of simplify this. You have b divided by 2, which is the same thing as saying b divided by 2, right? So what is that? That's 5 over 3, and you're dividing by 2. When you're dividing by something, you can always multiply by the reciprocal. So then instead, turn this into 5 over 3 times, the reciprocal of 2 is 1 over 2, right? It's half. Okay, so multiply that through, and that's going to give you 5 over, what is that, 6. Okay, so really what you're looking at is 5 divided by 3 divided by 2 is the same thing as 5 over 6. Now you can take that value and square that. Okay, and then that's usually a little bit more helpful. So now 5 over 6 squared, that's like saying 5 over 6 times 5 over 6. And then that's just 25 over 36. Okay. All right, so we have to add 25 over 36 to both sides. Okay, like I said, it got ugly because now we're dealing with fractions, all right? And unfortunately, we can't fraction bust it because then that's not gonna let us factor it, okay? So we have to kind of stick with it for now. Okay, let's do the right side right now because we have to take -3 plus 25 over 36. One's a whole, one's a fraction. We have to simplify it, all right? So first, in order to do that, you need common denominators, all right? So in this case, let's go ahead and do the work on the side, a little bit of scratch. You have -3 over 1 plus 25 over 36, okay? If you want the same denominator, right? Well, the common denominator here between 1 and 36 has to be 36, okay? Because you can't reduce the other fraction anyway. So you approach it from this side, you gotta multiply top and bottom by 36. Okay, so you got 25 over 36 plus here, the denominator is 36. 36 times 3, 108, I believe. Right, in this case, -108. All right, so now we clean this up. -108 plus 25, that's still going to be a negative. I believe that's going to be a negative 73. No. 25, 75, 70. No. Let me use my calculator real quick. -83, okay. -83 over 36, okay? So -83 over 36 is what we get, that's what it's equal to, all right? So because we have a negative, we should anticipate that later on when we take the square root of that, we're gonna end up with an imaginary number, all right? Okay, now the left side, okay, the left side seems like, what? Like, how are we supposed to factor this? Like, how is this even gonna work out? Okay, here is a cheat code, basically, all right? When you're dealing with something like this, the factor that you were looking for shows up right here, okay? And let me go back in case you don't believe me. Remember what the factor is right here? -3, guess where it was? Right there. Okay, other problem. The factor you were looking for, -2, guess where it is? Right there. Over here, what was your factor? -3, guess where it was? Right there. Okay, so Last one, the factor you were looking for, right there. So what can you do? Look for patterns, okay? Because factoring this right here is difficult, right? You're looking for what multiplies to be 25 over 36, but adds up to be 5 over 3. What? Okay. What you look for instead is, what is the value that's inside my parentheses right before I square it, right? So obviously we had to do some work, right? You had 5 over 3 divided by 2, okay? Once we simplified that, we saw that the factor that we're looking for, the one that we want, that's going to multiply to be 25 over 36, but then adds up to be 5 over 3, is going to be 5 over 6, okay? So then we factor this into y plus 5 over 6 times y plus 5 over 6, okay? And if you think about it, right, if you were to multiply 5 over 6 times 5 over 6, 5 times 5, 25, 6 over 6, 36, right? You can see the product, where it comes from. Now, the addition, right? Happy face, check this out. 5 over 6y, 5 over 6y, okay? Just to show you that it does end up becoming 5 over 3. You get 5 over 6y plus 5 over 6y, okay? Well, because they're like terms, right? They both have y, and they have the same denominator, you can add them up. So what does that give you? That's 5 plus 5, that's 10 over 6y. Well, 10 over 6 can be simplified because they're both divisible by 2. So when you divide both by 2, you go back to 5 over 3y. Is that not the same thing that you had here? Yes, it is. Okay, so if you get stuck on a problem like this, where you have to factor it, you go back to b over 2. Whatever b over 2 is, right, the simplified version, right, you notice how it's still inside the parentheses, but I haven't squared it yet. That is the factor that I'm looking for, okay? 5 over 6. Does that make sense? Okay, we got a thumbs up. Cool, cool, cool. Okay. All right. Okay, so once we have it factored, right, we can go ahead and then rewrite this. We can apply square root and we can finish. Okay, you can see why I left this problem till the end, because it's kind of ugly, right? All right, so now we can say this ends up being y plus 5 over 6 to the power of 2. That's equal to a negative 83 over 36. Okay, all right, now we're ready to square root both sides, and we can clean this up. So square root, square and square root cancel. Y plus 5 over 6 is equal to, here you're going to square root this, but you're going to get two solutions anyway, so bring down the plus or minus. I'm going to split this up into top and bottom, all right? It's the square root of the whole fraction, but if I have the square root of a fraction, I can leave it as the square root of the numerator over square root of denominator, okay? Here's why I did that. Because I cannot square root the top, but I can square root the bottom, all right? So I wanted to try to simplify it as much as possible. So here, y plus 5 over 6 will equal plus or minus. Well, the square root of negative 83, we're going to turn that into the square root of 83i, right? Because that's an imaginary value. 83 does not have any factors that I'm aware of. You can't divide by 2, can't divide by 4. Can't divide by 3 either. Okay, so 83 is a prime number. So we're going to leave it as the square root of 83. There's no factor tree you can make out of it. But the square root of 36, square root of 36 is 6. Okay, so we have a simplified version of that at least. And now the only thing left to do is get the y by itself, right? So we're going to subtract 5 over 6 on both sides. Okay, that's going to cancel out for us. Y is going to equal, on this side, even though they both have denominator of 6, do not combine them. Why? Because this negative 5 over 6 is a real number. The negative 83i over 6 is an imaginary number. So they stay separated by the plus or minus. Okay, so we have negative 5 over 6 plus or minus root 83, over 6i. Okay, and that's our solutions for solving the quadratic here using the imaginary value, okay? I'm sorry, using complete the square, but this is one example where you do get imaginary, okay? Let's check in on my chat. Okay, all right. Okay. Any questions, guys? I think that's kind of where I want to leave it today. I'm going to split this lesson up into 2 days, and then on Thursday we're going to do some applications of this. So how do we feel? Did we feel okay?